Good morning, students. Is this screen visible? Am I audible clearly?
Yes, ma'am.
Yes, ma'am.
Okay, thank you. Good morning, students. Am I audible? Is this screen visible?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Thank you, Beta. Thank you. So total 64 students are here. So ask student to join first. Now, students, today you are going to study open loop control system and closed loop control system. Now, in last lecture, just students are joining. So recap of last lecture, I am going to revise the classification of control systems. Meanwhile, okay. So students, you have studied classification of control system in last lecture. So first one is natural control system, then man-made control system, manual control system, automatic control system. I have given examples of all these things. Then after that, you have studied open loop control system, closed loop control system along with example. Okay. Today I'm going to give you the detailed example, detailed explanation about open loop and closed loop control system. Then you have studied linear and non-linear control systems along with the graph. Then time invariant and time variant system. Then you have studied continuous data and discrete data system. Then after that, stochastic control system and deterministic control system you have studied in last lecture. So today, students, you are going to study open loop control systems and closed loop control systems. So this is the diagram you are supposed to draw. So this is the diagram of open loop control system. Just a second, admitting students. So this is the block diagram of control system. Which type of control system? Open loop control system, which is having process as well as controller. Now this is nothing but your input to controller, which we are calling as desired process response. Output of controller is nothing but input to process. So this is the output of controller acting as an input to process. And output of process is nothing but processed output variable, that is controlled variable. So question may ask like this: draw the block diagram of open loop control system and explain its working. So for this, I have given the detailed explanation, that is nothing but ready answer for this question for your ready reference. So this open loop control system is physical system, which does not automatically correct variation in its output, and hence it is called as open loop system. There is no any feedback. Another point in this open loop control system is there is no any feedback from output to input, and hence it is called as open loop, okay, control system. So such a system may be represented by block diagram as shown over here. Okay. Now in this physical system, output is dependent on input. This output depends on process input, depends on controller input. Okay. But the controlling action or input is totally independent on output in open loop control system, or changes in output of the system. So in this system, the output remains constant for a constant value of input signal, provided there should not be any external disturbance or condition. Okay, so provided the external condition remains constant or unaltered, unchanged, that means constant. So this is what about open loop control system. Now you can write, you are supposed to write, students, like this answer for this question. So in any open loop control system, the output is not compared with the reference input, right? The output is not compared with the reference input. As a result, what happened? The accuracy of the system depends on calibration only. Just a minute, admitting students. Now, in the presence of disturbances, so I told you the disturbance, two types of disturbances, right? So in the presence of disturbances, an open loop control system will not perform the desired tasks. Open loop control can be used in practice only if the relation between input and output is known and if there are neither internal nor external disturbances in the system, in the process. Then only you can use open loop control system. Now, clearly speaking, such an open loop system are not feedback control system. So keep in mind, this open loop control system is not feedback control system. Okay. In feedback control system, there should be a feedback from output to input. So note that any control system that operates on a time basis only is open loop control system. So I have given example of toaster. The second example I have given that is related to traffic light that depends only on time. Time basis your output will be changing. So such a type of system is called as open loop control system. Now, for instance, traffic light control system by means of signals operated on a time basis is an example of control system. So we'll see one by one the example. Some of the advantages and disadvantages of open loop control system. So moving fast because this is theoretical part, you should know because question may ask based on this advantages and disadvantages of open loop control system. So advantages of open loop control system. First one is such open loop control systems are simple in construction because there is no any feedback element. Okay. So it is very much convenient when output is difficult to measure. Such systems are easy from maintenance point of view. Generally, these are not troubled with the problems of stability. There is no any problem of stability in open loop control system, whereas there is a problem of stability in closed loop control system. We'll see. Such systems are simple to design and hence economical. Controller to design a controller for such open loop control system is also simpler one. So these are some of the advantages of open loop control system. Now let us see the disadvantages of open loop control system. Very first is these systems are inaccurate and unreliable because accuracy of such system are totally dependent on the accurate pre-calibration of the controller. Main disadvantage. Second disadvantage is these systems give inaccurate results. Why? Because there are variations in the external environment. Because of this variation in external environment, you will get inaccurate result. Then third disadvantage or limitation, or you can say demerit of this open loop control system is these systems cannot sense internal disturbances in the system after the controller stage. And very important about recalibration. So recalibration of the controller is necessary. Time to time to maintain the quality and accuracy of the desired output. Calibration is very important. Okay, so these are some of the advantages and disadvantages of open loop control system. So I have given in detail for your reference. Now let us talk about example of control system. So very simple example of open loop control system is automatic toaster system. So this is the block diagram of open loop control system in which there is a process and there is a controller. Okay, so this is your process. So in process, your bread getting heated. Okay, and here in controller block, relays are present. So here controller block is having two inputs. First one is power input and second one is you have to set time. Desired time you have to set. Just a second. Admitting students. Okay, desired time you have to set. So two inputs are available for relays or for controller. First one is power input. Second one is desired time you are going to input. Okay. Now output of this controller or output of this relay, depending on that output, the braid inside this block, process block, getting heated. Heating process of braid is there in this process block.
Yes, ma'am.
Yes, ma'am.
Okay, sorry students, थोडंसं इलेक्ट्रिसिटी कट ऑफ झाली होती, लगेच रिझॉल्व्ह झाला प्रॉब्लेम. So just a minute, this is not our point. We are at lecture 1. Okay, are you with me students?
Yes,
जी
ma'am.
Yes, ma'am.
डिस्कनेक्ट झाली आहे त्यांनी कनेक्ट व्हा, परत आपण सुरू करूया. सो within a short period of time I am going to explain the examples of open loop control system. First one is automatic toaster system. So this is the block diagram of automatic toaster system. Okay, so you will get toasted bread at the output of your process. So this is nothing but example of open loop control system from day-to-day life. You are having all these things with you at home. Now, next wonderful example for open loop control system is traffic light controller. Again, in this, we are having controller and process. So what is process? Process are nothing but lights. Okay, green, blue, green, red, and orange lights are there. Okay, and output of this process is nothing but actual traffic control. Okay, and here in controller block we are having relays. Different types of relays are used. For that relays, two inputs are given. First one is power input, that is power and switch on off, and second one is desired time is given. So traffic flow control system used on roads is time dependent. Okay, the traffic on the road becomes mobile or stationary depending on the duration, or you can say sequence of that glowing of lamp. Okay, the sequence and duration are controlled by relays which are predetermined and not dependent on the rush on the road, and hence this is open loop control system. Next, second type of control system is closed loop control system. In some references it is also called as feedback control system. This closed loop control system is very important. We are going to study in this course all the closed loop control system, first order, second order, for different inputs. So closed loop control system in which feedback is taken from output and that is fed back to input. Okay, and accordingly your output of process that is coming to desired value. So let us see the block diagram of control system, that is closed loop control system. So feedback control system, a system that maintains a prescribed relationship between the output and the reference input by comparing them and using the difference as a means of control is called as feedback control system, just by using comparator or error detector, that is achieved. Now closed loop control system, so what are the elements and how it is working? The theory part is explained by here. So feedback control systems are often referred as closed loop control system. पहिलं या सब्जेक्टचं नाव काय होतं मुलांनो? FCS, feedback control system, instead of control systems. Right now your course title is control system. Initially in old syllabus the name was feedback control system. Okay, in practice the term feedback control and closed loop controls are used interchangeably but one and the same. In closed loop control system, the actuating error signal, which is the difference between input signal and feedback signal, is fed to the controller so as to reduce the error and bring the output of the system to desired value. That is nothing but at the output of process. The term closed loop control always implies the use of feedback control action in order to reduce the system error. Okay. Now I'm going to show you, just a minute, admitting student. Now I'm going to show you block diagram of closed loop control system. Students, you are supposed to draw this block diagram. This is the block diagram of closed loop control system in which controller is present, process is also present. This is your controlled output variable. This is nothing but your comparator or error detector, you can say. Now this first block is nothing but command input. Output of command input to given to reference transducer. So one form of physical quantity is converting into another form of physical quantity. That output of reference transducer is nothing but our RT signal. So what is RT? RT is nothing but in time domain. In time domain, I have drawn the block diagram. This RT is nothing but your reference signal. Okay. This ET is nothing but your error signal generated through this comparator. Okay. Now, for comparator, one input is reference signal, second input is BT. So what is BT? BT is nothing but feedback signal. The sample of output is fed back to input side through this feedback element, and that is nothing but BT. BT may be having plus or minus sign. So depending on this sign, plus or minus, you will get error signal. That is output of your comparator. That is given to controller block. Accordingly, controller is giving you output signal. This empty is nothing but input to process. So we are calling this empty as manipulated signal. This is manipulated signal. Okay. So that is given to process block. So this is the process which is to be controlled, and the output of this process is coming to desired value. This CT is nothing but controlled output. Controlled output. As feedback is taken, that means sample of output is taken, feeding back to input side through this feedback element. This is feedback path to input side to error detector or comparator, and hence the system is called as closed loop control system. So this is forward path and this one is feedback path. The various signals are given over here. What is RT, ET, CT, MT, and BT? I have explained all these things. Okay. So students, are you with me?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So you are supposed to draw the block diagram of closed loop control system. Question may asked based on this. Draw and explain the block diagram of closed loop control system. So moving first. Now the same thing is explained over here. So just read it first. The part of output which is to be decided by feedback element is fed back to the reference input. Okay. The signal which is output of feedback element is called as feedback signal, that is denoted by letter BT. So you have to remember this word BT. It is then compared with reference input giving error signal ET. So what is ET? ET is difference between reference signal and feedback signal. So RT plus or minus BT, equation for RT. So you have to remember this equation, and we are going to derive the equation for gain of closed loop transfer system. So for that, this equation is useful. Now, when feedback sign is positive, you can call this system as positive feedback system. If this is negative, if it is negative, that system we are calling as negative feedback system. In EDC or ADC, you ECA मध्ये पण तुम्ही शिकला असाल positive feedback and negative feedback. Okay, there are again two subtypes of positive and negative feedback. So here you have to remember only positive feedback and negative feedback. So when feedback sign is positive, we are calling that as positive feedback. When it is negative, we are calling that as negative feedback. So this error signal is then modified by controller and generated output and decides the proportional manipulated signal for the process which is to be controlled. Then the manipulation is such that error will approach to zero value. Now this signal then actuates the actual system and produces an output. That output is nothing but at up to desired value. As output is controlled one, hence called controlled output, CT, denoted by letter CT. So CT is nothing but controlled output. Now there are some advantages and disadvantages of closed loop control system similar to your open loop control system. Just a second, admitting Neeraj. So advantages: accuracy of this system is always higher, is always very high, because controller modifies and manipulates the actuating signal such that error in the system will be equal to zero. And that's why accuracy is very high. So this is important advantage of closed loop control system. Second advantage, closed loop system senses environmental changes as well as internal disturbances also, and accordingly modify the error. Third one, there is reduced effect of non-linearities and distortions. Then talking about bandwidth, advantage of closed loop control system. Bandwidth means operating frequency range or zone. So bandwidth for such system is very high. For closed loop control system, bandwidth is very high as compared to open loop control system. Now there are some disadvantages or limitations of closed loop control system, even though there are many advantages of closed loop control system. We are using in our course all system that is closed loop control system, but there are some limitations also that you should know. So very first is, closed loop control systems are complicated and time consuming from design point of view, and hence costlier. Design point of view means if you want to design controller for such a closed loop complicated system, it will take time and hence costlier. Due to feedback, system tries to correct the error from time to time. Continuous process चालू असते बघा मुलांना. Error correction ही जी process आहे, that is continuous in closed loop control system. So tendency to overcorrect the error may cause oscillations without bound in the system. So because of that corrective error continuously, there may cause oscillations in the system. Oscillations माहिती आहे ना मुलांना तुम्हाला? Positive value coming to zero, negative value coming to zero, again positive value, then zero, again negative value. So because of this, what you call feedback system, the system, closed loop system tries to correct that error. Okay, from time, म्हणजे continuous process चालू असते. Error correction ची process continuous चालू असते. So that's why there may cause oscillations without bound in the system. Just a second, admitting students. Then third limitation or disadvantage you can say, this closed loop system has to be designed taking into consideration problems of instability due to feedback. So The stability concept is a major part in closed loop control system. We are going to study the stability concept in unit 3 and 4. So the stability problems are severe and must be taken care of while designing the system. So this is what about advantages and disadvantages of closed loop control systems. Now let us have some of the examples of this closed loop control system. So very good example of closed loop control system is human being. Now, as all we are human being, can you please explain this example? Everything is in front of you. Anybody from your side? This is the closed loop control system in which process is there. In this process block, I have considered our hands. This is nothing but controller block. In controller block, I have taken our brain of human being. This is error detector, or you can say comparator. Now reference position of your book, or you can say anything, any object is taken as a reference position, that is input to comparator. Second input to comparator is nothing but feedback signal. Now this is nothing but your desired position of the hands. Okay, so sample is taken from output, that is feedback, through feedback element. Now here in human being, feedback element is nothing but our eyes, that is feeding back to comparator. Accordingly, error signal is generated. Brain is activated, controlling the action, that is nothing but process, and that process happens at desired value, that is desired position of the hands, that can be happened. So can you explain? Anybody from your side? This is the best example of closed loop system. No? Okay, just go to this slide. So this is the best example of human being, that is example of closed loop control system. If person wants to reach for a book on the table, position of the book is given as a reference. Okay, position of the book is given as a reference input. Feedback signal from eyes, that is taken. Okay, compares the actual position of hands, that is compared with reference position. Error signal is given to brain, error signal is generated, that is given to brain, and brain manipulates this error and gives signal to the hands. This process continues till the position of the hands get achieved appropriately. This is how our brain is working and acting as closed loop system. Take anything. इथे आपण फक्त बुकचं एक एक्झाम्पल घेतलंय. You can take anything. So this is a very good and best example of closed loop control system. Second example is vehicle speed control system. आता हे एक्झाम्पल तुम्हाला सगळ्यांना माहिती आहे, तुम्ही सगळेच जण व्हेकल चालवतायत, बरोबर? बाईक चालवताय ना मुलांना?
हो मॅम.
हा,
Yes, ma'am.
हो, तर मग तुम्ही एक्सप्लेन करू शकता ना? This is the again second example of closed loop control system, vehicle speed control system. Again here, this is the process block, this is the controlling action, this is nothing but actuator in between process and controller, and this is nothing but your feedback element, sensor. So in the process block, I have taken vehicle mechanism. This is my actual speed of vehicle is output. Okay. Now these actuators are nothing but our hands in order to apply brake through actuators. Okay. And controller is nothing but controller action is taken by brain. This is error detector again. Now this is reference speed, or you can say speed limit. And second input to your error detector or comparator is nothing but that is taken. Actual speed is taken through sensor, speed sensor, or you can just say by eyes you will get the speed, actual speed. Okay. Accordingly, error signal is generated, or you can say locomotive operates operator driving a train is a good example of manual speed control system. So the objective is to maintain the speed equal to the speed limits set. Now the entire system of speed control is given over here. So this is the second example of closed loop system. Okay. Now just compare two systems. Open loop, closed loop control system. Compare. Now students, for your reference, question may ask based on this. Compare open loop control system and closed loop control system. So along with block diagram, you are going to write all this comparison. Okay. Now very first, any change in output has no effect on the input. That is, feedback does not exist in open loop control system. Feedback exists in closed loop control system. So changes in output affects the input, which is possible by use of feedback. Then second point, output is independent on the reference input. Here output is dependent on reference input. Third point, feedback element is absent. Here feedback element is present in closed loop control system. Then in open loop, error detector is absent. In closed loop, error detector is necessary or present, you can say. Error detector is nothing but your comparator. Now in open loop, it is inaccurate and unreliable system, whereas closed loop system is highly accurate and reliable system. Open loop system highly sensitive to the disturbances, whereas closed loop system is less sensitive to the disturbances. Then open loop highly sensitive to the environmental changes. This closed loop is less sensitive to environmental changes. Bandwidth is small in case of open loop. Bandwidth is large in case of closed loop system. Now about construction of open loop. It's simple to construct and cheaper one. Closed loop system is complicated to design and hence it is costly. Open loop system generally are stable in nature, whereas closed loop systems are depends on stability. So stability is the major consideration while designing the controller for closed loop control system. Then open loop system highly affected by non-linearities, whereas closed loop control system reduced effect of non-linearities in case of closed loop control system. So these are the some points I have given for comparing open loop and closed loop control system. So you have to explain along with examples. Okay, I have given 2 examples. You can explain anyone out of 2. Just a second. Understood, students?
Yes, ma'am.
Yes,
Any doubt? Thank you,
yes,
Beta.
ma'am.
Pratham, thank you. Anup, thank you. Thank you, students, for attending the class. So today you have studied open loop control system, block diagram of open loop control system. Then I have given 2 examples of open loop control systems. Then after that you have studied block diagram of closed loop control systems. I have given 2 examples of closed loop control system. And then after that we have compared open loop control system and closed loop control systems. Okay, any doubt up to this? Total 68, 67 students are here. Any doubt, students?
No, ma'am.
Understood?
Yes, ma'am.
Yes, ma'am.
Okay, Aman.
Yes, ma'am.
Thank you, beta. Now, students, please write your roll number with understanding in chat box. Then you are free to move. So, first part of Unit 1 is completed. Now, in next lecture, I am going to take signal flow chart. Students, please write with understanding. Thank you, Aisha. Pooja, thank you. So please write with understanding. Understood, madam. If you are having any difficulty, then also you can write. Thank you, students. Thank you very much for attending the lecture. Thank you all. Thank you all.
Thank you, ma'am.
Welcome, Sachi.
Thank you.
Okay, thank you very much.